All right, I'm going to be doing problem 9, which is a 10-gram bullet traveling at 370 meters per second strikes a 12-kilogram, 1.2 meter wide door at the edge opposite the hinge. The bullet embeds itself in the door, causing the door to swing open. What is the angular velocity of the door just after impact? So I have the answer up on the screen, but obviously we are going to go through how I got there. All right, so the first thing I did is I just drew this lovely diagram. It says that the door swings at the edge on a hinge, so I'm just indicating that as like a free axle, so the door is gonna rotate around that after the impact of the bullet. And then the bullet is gonna hit right on the edge farthest away from the hinge, which isn't indicated as clearly as it could be, but it's gonna be all the way on the farthest left side. It's, yeah, not in the middle of the door, but way on the side. Okay, so how we are going to solve for the angular velocity is we're going to put together the two equations for our angular momentum. So we know that the angular momentum equals inertia times angular velocity, and it also equals the radius times momentum. And then momentum can also be written as volume times mass. So if we set those two equations equal to each other, we're given all of this information, so we can just solve for angular velocity and plug in our values, and we are good to go. So because our object is, it's like a flat plate, it's a board, so the equation for the moment of inertia for that is 1/3 of the mass times the length of the side that's being rotated around. So it's the width of the door squared. So if we replace I with that equation that I wrote down, we can solve for the angular velocity and get 3 times the radius times the velocity times the mass divided by the mass times the width of the door squared. So if we go in to input these values, it's going to be 3 times the width of the door, which we're given, which is 1.2 meters, and then times the velocity, which we're given at 370 meters per second. That's the velocity of the bullet, to be clear. That is linear velocity, so it's in meters per second. And then since this is the momentum of the bullet, we're, for this mass, this is only going to be the mass of the bullet. So that is 10 grams or 0.01 kilograms. And then divided by the total mass, because now this is the moment of inertia. So that's gonna be applied to the object as a whole. So we have the total mass as 12.01 kilograms, and then times the width of the door again as 1.2 meters squared. 1.2 meters, and then all of that squared. So if we put that into the calculator, we get 0.77 radians per second. And if you simplify all of the units we have here, you just get seconds on the bottom, so 1/seconds. And then since this is angular velocity, we can assume that the radians is implied. So that's what we get. This problem is important because it's just helping us practice setting up word problems, drawing out the diagram, and then identifying which equations have the variable that we need or variables that we have to solve for other things. So really the key is just putting together the information that we have to figure out how to solve for what we need.